working with matrices and applications, we need to have some fundamentals of matrix arithmetic under our belt. In this video, we're going to talk about how you add and subtract matrices, and then also how to do scalar multiplication. So to add or subtract matrices, they must have the same dimension. So we always want to check what the number of rows by what the number of columns are for each of the matrices that are involved in the arithmetic, to be able to see whether or not that arithmetic is something that is defined. And then if you've checked to see for add and subtracting matrices, if they have the same dimension, then you just add or subtract, depending on which one you have in the problem, corresponding entries. So here we want to perform these operations. Now with these two matrices, remember a matrix is just a rectangular array of numbers. I have a plus in between, so I want to add them. I need to check to see if they have the same dimension. So this first matrix, dimensions go rows by columns. So rows are horizontal and columns are vertical. So this first matrix is a 2, so 1 row, 2 rows, 2 by 1, 2, 3 columns. The second matrix is a 2 rows by 3 columns. So they do have the same dimension as each other, so I can add them. And then to add them, I add their corresponding entries. Now corresponding entries are that they sit in the same placement within the matrix. So first row, first column, the element that sits there, those are corresponding entries. First row, second column, those are corresponding entries. First row, third column, etc. So you get the placement matches in the matrices is what we're talking about with corresponding entries. So to add these two, I will just take and add the corresponding entries. So -4 plus 0 is -4. 3 plus -1 is 2. 2 plus 5 is 7. Then second row, -1 plus 4 is 3. -5 plus 3 is -2. And 7 plus 9 is 16. So this final matrix is the sum of those two matrices. Let's do a subtraction next. So I have 1, 2, 3 rows by 2 columns, a 3 by 2. We always say the number of rows first, the number of columns second. Next matrix is a 1, 2, 3 rows by 2 columns, again a 3 by 2. So I have the same dimension, I can go ahead and subtract them. So when we go through and do the subtraction, just think about it as you do the corresponding entries. So go 4 subtract 5, that's -1. -2 subtract 2, that's -4. 0 subtract -5, that would be +5. 7 subtract 9 is -2. 3 subtract 12 is -9. And then 6 subtract 15 is also a -9. So we have then our result of the subtraction of those two matrices. So adding and subtracting matrices, once you get the definition and how you have to look to see if it's defined and what to do, it's really a pretty straightforward process that you go through. Now the next thing in this is talking about how you do what's called scalar multiplication. Multiplication of a matrix times a matrix is much more involved, and it will be done in a separate video. But here to multiply by a scalar, that means you're multiplying a number times a matrix. And all you do with scalar multiplication is you multiply each entry by that scalar. So here I have the scalar 7 multiplied to this matrix, so a number multiplied to the matrix. And they might have a raised dot in between here, or they might just have that number sitting in front of it. Well, to carry out the scalar multiplication, I just multiply each entry by that value. So what we will get is 7 times -2 is -14. 7 times 6 is 42. 7 times 3 is 21. 7 times 5 is 35. 7 times 8 is 56. And 7 times 4 is 28. So again, not too bad in terms of the process to go through. Let's do this last one. So it's a scalar -3 times the matrix 4, 6, -1, 3, 2, -5. So we have our scalar that's going to be multiplied through. So -3 times 4 is -12. -3 times 6 is -18. -3 times -1 is +3. -3 times 3 is -9. -3 times 2 is -6. And -3 times -5 is a +15. So a scalar times a matrix gives you a matrix of the same dimension of the matrix that you multiplied the scalar to. And you just multiply the scalar to each entry to get your result.